demo of how InferX exactly works behind the scenes. So here on my screen you can see all these models here. So these are anywhere from 1.5 billion parameters to DeepSeek 7TB as well we got here. And usually in the traditional system this would take anywhere near 90 GPUs to serve all these models, right? So without any cold start penalty and on demand. So if you have to pre-provision the model, so that's how many GPUs it would take. But in our case, here we deployed all these models in two A6000 GPUs. That's a very low grade GPU with a 48 gigabyte memory each. You can see these models here, 60 models, and if you go to this section, these are the parts of the model, and these are the warm containers of the model, and they're ready to go as soon as the request comes into the specific model. And here are the snapshots of the models that are already been taken, and they are stored in the system memory here. Sometimes the model might take 2 GPUs or 1 GPU depending on the size of the model. So here you can see a GPU 0 and a GPU 1. So how exactly InferX works is, so when you manually load the model into the GPU VRAM, so we take the snapshot of the GPU state and the CPU state of the model, and if we freeze the state, and we store them in the system memory, and we only bring it to the GPU VRAM when there is a request, and as soon as the execution is done, and we evict the model, and we make the GPU VRAM available for the next workload. So let's see how it works. So let's, for example, so let's take the Quent 14B. So this is actually the cold start. So this is how fast it is in let's see, that's about it. So it's about 1.5 seconds. For the 14B model, if you in the traditional system, this would take anywhere from like 2 to 5 minutes to load the model. So, but in our case, since we're using our already deployed snapshots, so it takes 1.5 seconds. So what happens in the behind the scenes is, you can see here, so that specific model is actually in the GPU VRAM right now, and this it's actually using one GPU here, GPU ID GPU01. So that's what is happening. So that model in the GPU VRAM, and then we can quickly go back to a different model here. So let's pick 70B model, DeepSeek 70B, and then let's give it a go. That's about it. It's about 2.5 seconds. It is actually A6000 GPU. It's much slower, but if you're running it on the H100, it's much faster. We can get the cold start under 1 second, literally. So if you go back to where the model is, see that the DeepSeek 70B is actually it's in the GPU VRAM, and it's using 2 GPUs, because you can see GPU 0 and the GPU 1 right here, because it's a bigger model, the 70B model, and it needs more memory. So the old model gets evicted, and the new model comes into the GPU VRAM, and these are all sharing the same GPUs. So just like that, you can go to any model, and you can give it a go, and just like you can serve any model on demand, and you go back to the pod, see that the new model comes into the GPU VRAM, and the old DeepSeek 70B gets ejected, and the GPU compute becomes available for the next model. So that's how you can keep on serving the models on demand, and so the end user is only serving, only being paid, only charged actually for the execution of the model, for those couple of seconds when the request is coming in, and as long as the inferencing is done. So that's how it is. So just like I said, so all 60 models were deployed on 2 A6000s instead of 90 GPUs. So that's how efficient it is. And InferX can be deployed on any GPU out there. It's just a plug and play. It just sits on top of your GPU, and then we orchestrate the models in and out, and we directly control the GPU and do the model management and the memory management as well. So that's how we enable serverless environment for the GPUs, for the large language models in real time as well. And this is done in a very multi-tenant secure manner, because we built a secure container runtime to orchestrate these models as well. So that's a very low level container runtime that sits right on top of your GPU. Yep, I hope that makes sense, and please reach out if you have any questions. Thank you.